with where I stopped. Okay, so this was the example that we were doing. Yes. Yes. I think you attended the class. Thank you. Okay. Hello. Okay, this was the question we were doing last time. Okay, and this is the A. This is omega naught. This was the question we did. And this distance was total 3 meters for this rod. I'm not going to do this problem again for you. You will have to watch the recording that I will post today. But I will definitely do an alternate solution. And just remember that we got from the free body diagram in rigid body kinetics. This is what we got last time. This is the normal AN that we got. This was the center of gravity G. The weight that we got was this one. The weight that we have is this one. And this distance is 3 meters. This was 80, if you remember. So this is the example we did last time. Today I will do an alternate solution. I think someone has, let me pause the recording. The recording, summation of moment about A equal to IA alpha and okay, what is this alternate solution? Last time, this is what we did. If I remember correctly, when was the class last time, by the way? 20 or 19? 20, I think. So on 20, on the 20th class, this is the solution I showed you. We did summation of forces. Then I did summation of moments about the center of mass is equal to Ig alpha, correct? And then we found, you can even see from here, MA plus AT into 1.5 equal to Ig alpha, because at the end of the day, there is a moment as well, right? MA. Today, we have changed our strategy. Now I am doing the summation of moment about the point of rotation. How many students agree? Now I will write, let's say clockwise is my positive MA in rigid body kinematics. By the way, this topic that we started last time is rigid body kinetics. I apologize. Now, weight will also have a clockwise moment about this, multiply by R, which is equal to IA alpha. So anyone who can tell us what will be the value of R?
It will be 1.5 meters, right?
1.5 meter. Yes. And by the way, what is the value of MA? We have to double check from the given notes. I think the MA that is given to me in the problem is 60 Newton meters. So someone has applied a moment of 60 Newton meter on this rod. So I will put 60 Newton meter here because it is given to me. Weight was given to me as 20 kilograms multiplied by 9.81. R, one of the students said, is 1.5 meter. It is equal to IA alpha, correct? Okay. What is the value of IA?
We need to know the formula for this one.
Huh. So moment of inertia about the point of rotation. Google it. So you have to Google this. Google moment of inertia of cylinder rod about its one end, about its center. So again, Google it. Moment of inertia of a cylinder rod, SLENDER. Moment of inertia of cylinder rod, that is about its center. But the moment of inertia of a cylinder rod about one end is different. Why? Mitch, why? Because if I have this rod, if I rotate it like this about the center, it will have a certain rotation, right? What if I rotate it from the end? So I just join with something here and I do like this. So now the pen will rotate about its corner. Both the moment of inertia has to be different. When you rotate about the center, then the very good. I'm not sure how did you find it, but he's right. I think he used Wikipedia page probably. You can use Wikipedia as well. Moment of inertia of cylinder rod, Wikipedia. 1/12 ml square about its center of mass and 1/3 ml square about its one corner. I am waiting for Usman and Hussain to Usman Bahadur and Hussain to just double check. Moment of inertia of a cylinder rod. Okay. So you can double check Wikipedia. Okay. Now, how did Wikipedia tell you? This is how Wikipedia told you. 1/12 ml square plus. What is this distance? Let's say this distance is L by 2, right? So you will do M R square, right? Or you can, students who don't like this, IG plus MR square or MD square. Correct? Yes, no? 1 minute, 1 minute, sorry. Okay. Now, what is the answer to this whole thing? 1/3 ml.
So it's the same as the strength of material class, right? We try to find the moment of inertia with respect to new mutual axis.
That is area moment of inertia. This is different. What is this? What is the name of this? This is moment of inertia. That is area moment of inertia. They have different application, but the concept is pretty much the same. But in area moment of inertia, if I bend it like this, it resists. If I want to bend it like that, it resists. This is different, although both are resisting. That is resisting in terms of bending or whatever, the structural mechanics part. This is resisting in terms of the motion. Did I answer your question or not? No? I did, but they are different. Okay, now you write 60 Newton meter plus 20 kg into 9.81 meter per second square into 1.5 meter. What is the value of alpha? How many of you did not attend the last class? Out of curiosity, if you can raise the hand. You did not, you did not, you did not, you did not.
I still jump.
You did. You did. I remember. So if you miss the last class, it's so difficult to join from this point, but that's fine.
Yeah, but if the words and each one and strengths of materials exam, maybe all of us would the job.
I understand, and I actually agree with you. Okay, what is the value of alpha?
We will write by the moment of inertia, we will find alpha, right?
Absolutely.
It will be 5.9.
Good. Perfect. This is the right answer. Now that we have done this question, let us. Okay, should I revise few things on rigid body kinematics because so many of you did not come? Yes or no? Okay, so in rigid body kinetics, we started. If all of you can focus, Mitch, I'm doing this for all of you. Ghazal and Hussain and Bahadur and you as well, if you did not attend. The question? Sorry, this one? Yeah, this one is parallel axis theorem. So I wrote the formula, moment of inertia about this point equal to, I apologize. The summation of moments about this point is equal to moment of inertia about this point multiplied by the alpha of the rod. Since I started talking about the moment of inertia about this point, I said the moment of inertia of the slender rod about its center of mass, that is center, is 1/12 ml square. What about this point? Then I use the parallel axis theorem plus mr square or md square. What is the value of d? D is the distance from the point about which you wrote the formula for moment of inertia, distance from that point all the way to the point about which you are now trying to find the moment of inertia. So this distance is L by 2 if the complete distance is L. So that's why I did 1/12 ml square from Wikipedia plus ml by 2 square to give me 1/3 ml square about this point, which also one of the students already told me by looking at Google formula. So just to revise what we did last time, because so many of you did not come, summation of forces, summation of moments about center of mass is Ig alpha. Kinetics of rigid body motion means that we are talking about now objects whose sizes do matter to us. Kinetics of rigid body motion. We said that in translation, the angular acceleration is 0, right? So summation of moments about center of mass is equal to Ig alpha equal to 0 and alpha is 0. But I told you something very strange. I told you that even in pure translation, when I'm trying to do the summation of moments about another point A, it is equal to Ia alpha. Focus on the subscripts. But now Ia alpha, this alpha is not 0, which is so strange, which is equal to Ig alpha plus Magd, and I said this alpha is 0. Then I said in a rotation problem, of course, in general, alpha is not equal to 0. I told you all the different ways you can find the moment of inertia. We did this problem, by the way. You can see this rod. In this problem, I did the summation of moments about the center of mass. I equated to Ig alpha. I found the value of the angular acceleration if someone is applying a certain moment. I also said you need to give me the reactions at this pin. So I will go to the next topic, but before I do that, why don't you answer this question? What will be the reaction on this pin if someone has told me that the mass is 20 kilogram? Then what will be the reaction on that pin? 20 kilogram is the mass, so it will be
20 kilogram times
9.81.
times the
mg.
alpha, yeah, mg.
That's it. That will be the reaction of the pin. That's it. No. The answer is no. Why? Because this is not structural mechanics, statics. This is not like a rod 20 into 9.81 acting here. What will be the reaction of the pin? 20 multiplied by 9.81. No, the rod is rotating. This is dynamic problem. When the rod is rotating, then the AY, that reaction is 20 into 9.81. All of you are correct. But there will be another reaction, the horizontal one. Why? Because when the rod is rotating, then you will have normal acceleration. Because of normal acceleration, omega square r, you will have MAN. Because of MAN, you will have a AX as well. So now you have AX and AY. AY comes from your static problems, but now you have a dynamic problem. Anyways, this is just a quick revision for you to motivate, for you to get motivated and revise your lecture. You have to watch that recording in which I explained all of these things.
Hocam,
Yes, yes.
could you go into the previous slide?
Yeah, I will. Why not? The last lecture or
No, hocam, the slide which you write in there, the first slide, hocam. So the alpha, we found that 5.8, right?
Mhm.
So the alpha is towards the page, right? The direction of
Clockwise.
the alpha will be
Ah.
same as the omega 0.
Clockwise?
Clockwise, okay.
I think so. Clockwise is what I presume, yeah, because clockwise is positive, answer is
We
positive.
consider as positive, so therefore clockwise.
Yes, absolutely. And why don't you all now do this problem for me? Let's say this is our problem of today. Please do revise last lecture yourself. You have to watch the recording. So let's say this is our okay. Let's say this is your point A or G. We don't care. The question says that we have okay, and we have a nice and beautiful let's say so this is our little mass MB equal to 20 kilograms, correct? Find alpha of the pulley. Why? What is the question? The question says that your R is 0.4 meter and M mass of pulley is 60 kilograms and the radius of gyration is 0.25 meter. Okay. Okay, do it. Tell me. Why don't you tell me the first strategy? A and G are the same points, by the way. It's you can call this point as A or G. So summation of moment about, let's say this point G or A. I'm calling this point as A or G, whatever. Let's say call it G is equal to IG alpha. Okay, then before I start the problem, I have to make free body diagrams. So first free body diagram will be, I will have the same fellow like this. Then I will have, oh, sorry, something like this. Then I have, so let's call this as T in the free body diagram, and this is my, I don't have that much space, so let's make it smaller. This is my WB. And this is my T. I will call it as T. Okay, so this is my T tension, right? And then I have this as the hinge or pin. This is the weight of the pulley. And this is AX. And this is AY, correct? Yes, no? Okay. And what about the kinetics diagram that last time? Kinetics diagram means that you talk about now the accelerations, and you can put it on the same free body diagram but with different colors. But I am putting in a separate form. This is my alpha. And I can say this is, let's say, AB. And this is my kinetics diagram, KD. So I will say AB equal to R alpha, tangential acceleration, and alpha is equal to 11.3 radian per second. So I found it from here. Hang on, how did I even find it, by the way? Did I give you AB or alpha? Ah, sorry, I apologize. I did not give you alpha, so you have to find it. So the question says that you have to find alpha. So now do the summation of moments about center of mass and do the summation of forces in the y direction. Do it. Do the summation of moments about center of mass. Understand? Do it. Mitch, do the summation of moments about center of mass for me. AY is upward, weight of pulley is downward, AX I assume towards right. Do summation of moments about center of mass. IG value I did not give you. I think for a disk it is 1/2 MR scale. I don't know. I have to double check. So probably someone can even Google it. Anyways, or probably I will do it. Maybe instead of Googling it, you just write the equation. I will Google it myself.
Hocam, is it solid disk?
I have to double check. That is a good question, by the way. A solid, hollow, it also creates problem. Oh, sorry. Why am I saying it? kg is given. I apologize. Radius of gyration is given. Oh, come on. So radius of gyration means m kg square. That is the formula when radius of gyration is given. Okay, what about this left hand side? It will be anti-clockwise T multiplied by R. So I will write positive TR and anti-clockwise is positive. Okay, and this is mass of pulley. Now from here, all you have to do is find the value of tension, but you don't have tension, so you will write summation of forces in the y direction is equal to
10 times.
MBAB, very good, because that's the only thing that is moving. Then the tension is upward, minus T. The weight is downward, let's say positive is downward, equal to. Then you have MB, and acceleration is nothing more than R alpha, right? Because look, if this is the acceleration of this point, what will be the acceleration of this point, this point, this point? It will be R alpha, right? Because tangential acceleration is R alpha. Is this clear to Usman and Ghazal and Mehmet and Hussain, Mirch? And to Damir as well, that tangential acceleration is R alpha. So it's the same thing. R alpha, R alpha, R alpha, R alpha. Because the rope is coming from here. So if that point has R alpha, so it is R alpha, fortunately or unfortunately. Because it's a rope, right? And the rope is going down. So I would assume that even that is R alpha and R alpha. Although the R alpha is only applicable on circular. Okay. So from here, you need to give me the value of two equations and two unknowns. Do it. No one found it. Okay, since none of the students told me the answer, I will tell you that alpha comes out to be 11.3 radian per second.
Hocam, why T is minus?
Yeah, because if you focus on this part only, right? So I am considering my downward as positive because because somehow the question told me, let's say that the mass 20 kilogram is going downward. So I had this intuitive feel that the disk has positive alpha in the alpha is counterclockwise and the mass is accelerating downward. Since I had that feeling, look at here, I had this equal to positive MBAB, right? So my positive MBAB, the positive is downward for me. That's why I was very careful that I considered my weight as positive as well. Otherwise, you will have wrong answer. So that was a very good question by him, by the way, because you cannot just randomly say positive upward I will take. No. In this particular question, I have that intuitive physical feel that as the mass is going downward, it is falling, it is accelerating downward. So if it is accelerating downward and I'm writing MA, then acceleration downward is positive. Mitch, I did answer your question, right?
Hocam, can I solve? In the equation of what is T?
Tension.
It's equal to weight of B.
minus T plus WB equal to MR alpha. I wrote here. You mean, oh, एक minute. You mean
I'm talking.
here?
Yeah.
No, it's the same thing. This T and this T are the same T's. When I was writing summation of moments about center of mass, I said, I took this chunk separate. I said T multiply by R equal to IG alpha, right? And when I was wondering what is T, I focused here. Look, this. So this T and this T are the same, okay?
So T is equal to weight of B.
T is the tension. Nahin, T is not equal to the weight of B. Usman, if Usman Bahadur, look, this is T, this is WB minus T plus WB is equal to MBR alpha. Yes, yes, my man.
Hocam I found the 13.75 for the alpha.
Quite possible that my notes are wrong, but I have alpha 11.3. Now, just to answer your question, there is another way of solving this problem. Let me double check if my mic is not mute, right? Hello? Okay, mic is not mute. Abu, you can hear us, right? No? Okay, Abu has responded. Thank you, Abu. So, just to be clear, there is, hang on. This is tension at this point, tension at this point. So both of them are T here or T here, okay? Let us do this problem with another strategy, because apparently students are getting confused. Why did you convert one problem into two problems? We don't like it. So for those students, I will do this problem again. So we will have WB this is your weight of pulley. By the way, I'm coming to your desk. I want you to do this problem yourself. Now with this method, I will tell you what is the method and you do it. AX, this is your AY, and now students are getting confused. Isn't it the center of mass of the pulley? And I will tell them, yes, you are right. This is the center of mass of the pulley or point A. That's why I said I will keep on alternatively use A or G for this one. Acha. So what I will do is I will take a big chunk. So I'm coming to your desk now. Let's see if you can do this yourself. Again, you write point A and G are the same as you wrote on the last slide. Summation of moment about center of mass is equal to IA alpha. I apologize. Summation of moment about point of rotation, I mean, which is center of mass of pulley, is equal to IA alpha. Then you write anti-clockwise is positive. Summation of moments about point A is equal to, okay, now tell me what should I do? So it will be IG alpha plus MAG MABD, correct? So this will be MB. In other words, you have WB RP equal to MR square, which is Moment of inertia formula if, I'm sorry, mk square if radius of gyration k is given to you. I told you in the last lecture, plus m b rp alpha rp. Alpha equal to, find the answer. So do it. What is RP? I will answer your question. If you can give me just 20 seconds. RP is the radius of the pulley. Or so what I'm doing is I'm multiplying the AB is R alpha. So this mass MB multiplied by the acceleration. This will give me a certain force like this. That will be multiplied with the distance RP to give me a moment. So that's why, can you, Mirch, Hussain, Damir, everyone, you are following me, right? MA multiplied by RP. MA multiplied by RP. This is the moment arm. Like this, right? Yes, Mehmet.
Hocam, I understand the formula, the total moment of which total moment equals to moment of inertia A times alpha. And after that, we exceeding the formula as
Because I changed the subscription. Previously, you have subscription. Submission of moment about A is equal to IA alpha, but in the next line, when I wrote summation of moment about point A, look at the right hand side. I did not write IA alpha. Now I said it is equal to IG alpha, then definitely I have to add something.
why are we putting MB times AB times C? Which is MB and which is
This is
AB?
MB.
Okay.
So this is mass of the block,
Mhm.
MB. When you multiply MB with R alpha, what do you get? You get the force, MA. And when you have got the force MA, all you have to do is multiply with the moment arm to get the moment which this mass exhibits. So now you have I alpha along with this one, you add them together and you can have, there are students who are saying, but why did you put WBRP on the left hand side? So you can see that WBRP will give me the anti-clockwise moment. This is equal to the fact that this fellow accelerates and this fellow also accelerates at it falls down. So actually WBRP gives me the moment. And it is equal to MP K square alpha plus MA multiplied by RP.
So why is there no tension?
That is a good question because if you remember, when we divided the problem into two parts, so please remember it's the same problem. I will again get alpha value as 11.3. I will answer Hussein's question. When I divided the problem into two chunks, that's when tension came into the picture. But when I'm taking the whole problem as one chunk, tension even doesn't show up.
So on the left side where force is, there is no tension, maybe we will not consider the tension.
Yeah, because I have this as an external force. I just don't have tension that is coming when I take the complete object as one. But when I take it from here,
Oh, yeah.
and this separate and that separate, then tension just pops up. Right? Yes,
So-
Mitch. No, sorry, I will take Mitch.
You said A is the G, right?
Huh?
A is the G, right? A point. is
Huh,
the-
point A and point G is the same thing.
So how can we write the first formula?
how the top and the first floor,
Yeah, this one.
how is related to I first to second. Yeah.
Oh, okay. That is a good question.
Yeah, John, we said M
It's the same point.
yeah, we said M equals A, then we said M equals A and B.
Ek minute. I understand. The question is very good. Okay, look, I did explain last time that when I'm doing summation of moment about center of mass, that is Ig alpha. But when I'm talking about point A, if I want to convert it into G, then it becomes something like this, Ig alpha plus MAGD. Mate's question is, but point A and G are the same thing. Mirj is right, by the way.
Hocam, can we erase the first question? First equation.
Really? No, I don't want to. Ek minute. Well, we can merge if you want. Ek minute, but what is the problem in this and this? Summation of moment about point A is equal to I alpha. That is correct. But that is equal to Ig alpha plus MB ABD. Because you will say IA is Ig.
No, it's translational plus rotational, right?
Like this one. Yeah, the fact that this thing is translating and then multiplying with the D will give us a moment, and Ig alpha is the moment of inertia about this point. So I will take your question. So WBRP generates an anti-clockwise like this, and this gets expanded into, this gets utilized into two components, Ig alpha and MB ABD.
So we thinking as IA as a whole system's moment of inertia, right?
About
not,
what?
not the cylinder. And not the
Ha,
circular.
This is the answer to the question actually, Mirj, that when we are doing the summation of moment about A is equal to IA alpha, you see that big box that I have drawn. So the summation of moments of the whole system's objects about that point A. That's why when I wrote it again, I have to say it will be equal to Ig alpha plus MBAGD. So that's why there is a big box here, that for the whole system, I'm doing the summation of moments about that point A. Okay.
So therefore, when we're talking about total moment at A, we are not looking at the internal forces or
No.
yeah, like tension is an internal force.
No, we will not take them because
So we're just taking the external force, which is the VB.
absolutely.
And we multiply it.
Or you cut it into two and take them separately. I'm not sure which method do you like most, this one or that one.
So we should trace theoretically the total sum.
Huh?
First equation.
Say that one more time, Mirj.
I guess we should erase the total sum in the first equation.
This one.
Yes.
Honey, that's fine. I think this is correct, but it's okay. Summation of moments. Summation of all moments about point A. You only have how much time? 1 minute?
Just 1 minute.
So what I will do is I will post the recording of last week's dynamics class as well. You may want to revise them. Rigid body kinetics is what we will be doing during the next 3-4 weeks. And that is pretty much one of the last topics of our semester. Abu, do you have any questions for us? The class is pretty much over. Okay, gentlemen.
Geleceğim.